Okay, sorry to the supply teacher. My child was awake all night, sick, so I was unable to finish the videos last night. I'm going to finish them up right now. They will be uploaded as the day continues. So back to this question here. We're just going to assume then we're solving -5 bracket x plus 3 over 2 is equal to 7. So what would the first step be, please, to Tanner? Okay, good. I'm going to hopefully multiply each side by 2. And that's going to remove the fraction. So that's going to change my equation into 6. Oops. Hopefully. Is less than or equal to -5 x plus 3 is less than or equal to 14. Alright, Austin, I want to get rid of that -5. How do I do so? Great. Now I'm going to divide by -5 and flip the inequality. Now again, you're going to do that to everything. I'm going to, unfortunately do this with fractions. As my computer's dying here. You should always use fractions for your questions and not just excuse me, no decimals there. So I'm going to call this then, it's my bracket, -6 over 5 is greater than or equal to x plus 3 is greater than or equal to -14 over 5. Now note, the greater than less than sign's flipped as well as the signs. Okay, so make it a little bit bigger so you guys can see. There we go. Okay, so the greater than less than flipped, and also the 6 turned into -6 over 5, and the 14 over 5 turned into 14 turned to -14 over 5. All right. Mine's gone blank here. Who's next? Oh, Julia, sorry, Julia. Last step here to get rid of the plus 3. Great, we're going to subtract 3 from everything. Okay, so I'm going to paste that, and then we're going to edit that. -6 over 5 minus 3 is going to be 15 minus 6 is 21. And 29. I think. If I made a mistake there, supply teacher can fix that hopefully for me. And there we go. Alright. Okay, one of these will be on the test. I will make sure we review this again. Let's throw another example on here. I'll do C. You guys can do D then yourselves, okay? So letter C is going to say solve. We'll say x squared minus x minus 6 is greater than 0. Okay, so the way we're going to do this, and we did this a little bit last week, hopefully you understood when we did it. So what we're going to do is we're going to find the roots by factoring / quadratic formula, do a rough sketch, find when the y values are greater than 0. Okay? So, Matt, you're going to show off your factoring skills. And by the way, if I'm going too quickly, remember, just raise your hand and hopefully the supply teacher will hit pause for you and pause the video. So Matt, I'll let you factor this. What's x squared minus x minus 6 less than 0? What does that factor out to be? Okay, good. I hope you said multiply to -6, add to -1, so it's going to be -3 and 2. So it's going to be x minus 3, x plus 2 is greater than 0. My roots are going to be 3 and -2. Now luckily I have a beautiful graphing program here. So if I put down y equals, or not, y equals x minus 3 times x plus 2. So what I want you to do here, if I can find my settings here, x will go from maybe about -5 to 5, and y will go from maybe, I don't know, -15 to 1. Hopefully that's okay. Okay, so if you take a look now, I'll move that graph a little bit so you can hopefully see. Can I make that bold? Hope you can see that. Basically what I want to know then, back from my equations, I want to know when this graph is above 0. So when it's going to be above 0 is going to be, it looks like it's going to be over here, and it also looks like it's going to be here. In fact, I'm going to put the lines in here. X equals -2 and x equals 3. I'm going to put those both in blue if I can. Oops. Can I change that to blue? Maybe I can't. Oh well, okay. The point is, though, I'm trying to say here, if you look at the graph here, in this domain in the middle, between -2 and 3, sorry guys, I'll just draw this the numbers on the graph here. Whoops. What happened? Oh. There we go. So I drew the numbers on the graph here so you can actually see. So when x is less than -2, the y value is positive. When x is bigger than 3, the y value is positive. But between -2 and 3, the y value is going to be negative. So we're going to say from our graph then, our solution, x is less than -2 and x is greater than 3. So just going back to what I did there, right, looking at the graph, alright, so the y value, we want to know when this graph is above 0. We find our roots, do a rough sketch, and then find whether the graph's going to be above or below 0 at a specific point. Alright, I would like you guys to try this one for me right now. If you need to hit pause to get that down, go ahead. Letter D is going to be solve, we'll say 2x squared minus x minus 6 is less than 0. So what you should do, you should factor it first, then do a rough sketch and let me know when the graph is below 0. So what I'd like the supply teacher to do is hit pause in the video right now and give the class maybe about 5 minutes to try this out, or till people are mostly done, and then we'll take it up. Okay, great. Ryan, you're going to be up first. Can you give me the M&A for this question? Because we have to factor this. Multiply -12 at -1. Great. Ryan, what are the two numbers? -4 and 3. Great. Okay, good. Tori, can you tell me what to do, please, with the -4 and the 3? 2x squared minus 4x plus 3x minus 6 is less than 0. Just to recall for the class, I can't directly go to factoring in one step because it's a 2x squared instead of a 1x squared. Alright, Natasha, can you do some common factoring for me, please? Great. 2x, x minus 2. Oops. And on the right hand side? Great. Excellent. Wonderful. Tremendous. Alright, Owen, can you give me the next line, please? Okay, great. So it's x minus 2 and 2x plus 3 is less than 0. Wonderful. Taylor, can you give me what my roots are going to be now, please? Okay, great. Positive 2 and -3 over 2. Alright, so what you should do right now is do a very, very rough sketch. Alright, the graph's going to open upwards because the a value here is positive. Alright, so if I graph this, let's get rid of some of these. And I call that y equals, actually since we're in functions, let me call it f of x equals 2x squared minus x minus 6. Okay, let's maybe change that scale. Actually, it looks pretty good. Okay, so there's my graph right there. I'm going to put my roots in here as x equals 2 and x equals -3 over 2. Now you don't have to draw those in there, but it probably doesn't hurt. Okay, so there's can I do that? Can I change that color? Oh, I can. Beautiful. That'll be a dotted green. Oh, that's probably too hard to see. Dotted red, and I know I could do that. And dotted red. Okay, so basically what we want to know is there's my graph, there's my roots that open upwards, all is good. Probably for the class it won't be as fast as I am, but if you need to pause, the supply teacher, feel free to do so. Okay, so there's my graph, all's looking good. We want to know when the graph is less than 0. Alright, so James, can you please be brave and tell me when this graph is less than 0? You don't know? Oh goodness, James, come on now. I'm just joking. James obviously knew the answer. But what you'd be looking for here is when the y values here are negative. So the y values up to the left of this are going to be positive. Okay? To the right of 2 are going to be positive, but it's going to be negative between negative 3 over 2 and 2. So my answers here is going to be my solution. X is negative 3 over 2 is less than x is less than 2. So back to domain again there. Let's see if I can put them both on the same page. Oh, look at that, I can. This is going to screw me up later, but that's alright. Alright, so negative 3 over 2, the graph's going to be negative in that spot right there. Okay. Alright, I'm going to move ahead now, guys, to graphing rationals, like what we did before. Once again, supply teacher, if you need to hit pause or people have questions, if it's a supply teacher that I think it is, she is a wonderful future math teacher, okay, at her school. She's going to be, so she can help out with all this stuff very, very well. If there's questions, please feel free to ask. If you need to add something, please feel free to do so, and we'll go from there. Okay, so here we go. Graphing rationals is going to be the next section. I'm going to. Okay, so this is going to be our steps. So the steps to do this are going to be as follows. Number 1, factor everything. 2, you're going to state your asymptotes. That's going to be a line that the graph comes close to, but doesn't touch. 2a, these will be the restrictions, and also y, is there not equal to? Oh, perfect. And y cannot equal to 0. Then you're going to sketch a graph drawing the asymptotes, and then you're going to make an interval chart to show where the graph is positive and negative. Okay, so what I'm going to do is I'm going to hopefully do about 3 examples of this, and then we will, then that'll be it for the day. Please feel free to ask. If I'm going too quickly, which I know I am, supply teacher, feel free to just hit pause, and we'll go from there. Here we go, example 1. Graph, make a nice one here. Oops. F of x equals 3 over, we'll say x squared minus 9. I'll make it a little bit bigger and move this up. Okay. Alright, Nathan. Very first step is going to be what for this? Okay, hopefully you said factor everything. Okay, so what I'd like you to do, Nathan, is factor that denominator. How do you factor that? Okay, I hope you said difference of squares, so that's going to be x plus 3, x minus 3. Great. Alright, now, for Alistair, can you tell me please what my asymptotes are going to be? Okay, good. So x cannot equal, will that be that? 3. X cannot equal, whoops, negative 3, and y cannot equal 0. Where the 3 and the negative 3 came from was the restriction here. That divides by 0, so if you plug in 3, if you plug in negative 3, that divides by 0, and always in grade 11, you're going to have the asymptote y cannot be 0. I'll go back to my lovely graphing program here. I'm going to delete all these graphs. Okay, and there's 3 and negative 3. I'm going to make this maybe a little bit wider. Not real wide, but maybe to negative 6 and 6. Okay, let's go back here. Okay, so I'm going to put my asymptotes in here. I'm going to say x equals 3, x equals negative 3, and y equals 0. So all I did there, if you take a look, and I'm going to edit these hopefully. I'll make these all green. Hopefully you can see that. Maybe let's do red. Red might be easier to see. Yeah, red's easier to see. Okay, so what I'm going to do is I'm just going to draw all the asymptotes on in there in red dotted lines. In the classroom I'll use green because I like that better. Okay, but what I've just done there is I've made a nice graph. I can sort of see where the breaks in the graph are going to be. I'm going to try and see if I can leave the graph and the paper here together. Look at that, the power of technology, I can. Lovely. Okay. Okay, so I put in here, this is the line x cannot be negative 3, this is the line x cannot be 3, this is the line x cannot be 0. Okay, now I'm going to make what's called my interval chart. This is going to show where the graph is above and below 0. What I'm going to do is I'm going to write f of x over there. And underneath f of x, I'm just going to list all of the different parts of my graph. I'm going to maybe move this over a little bit to make it easier to see how we're going to do this. Yeah, let's go to there. Okay. All right, so let's move this over maybe a little bit there. Okay, so f of x, what I'm going to list is every factored part of my graph. So I'm going to write down a 3 here, and x plus 3, oops, x minus 3, and overall, and a test point. Okay. In the next column, I'm going to label my graphs here based on the different breaks. Because this line here says y is can equal 0, sorry, because this line here says y can equal 0, that means the graph is either going to be below or underneath the line. Okay, so my first segment is going to be x is less than negative 3. Back to my graph here, what that means, if I can move this over, which I think I can. I don't know how I'm going to do that. That's okay, I'll leave it there. That means everything on the left side of negative 3 is either going to be above or below. Okay, it can't cross. The next segment is going to be between my two asymptotes, so I'm going to say negative 3 is less than x is less than 3. And then my last chunk is going to be on the right, which is x is greater than 3. Okay, so where I got that from is sort of my asymptotes basically go right in here. Okay, then I'm going to, at the bottom, I'm going to choose test points. These are just going to be numbers that fit. So a number less than negative 3 is going to be negative 5. You can choose a different number if you want to. That's what I chose. In the middle here, I'm going to choose 0, because 0 is between negative 3 and 3. On the right, it's going to be 5, because I want to choose that one. Right. Now, this value is not, there's no x value in, so you know what, no matter what I plug in for x, this value is going to be positive. On the next example, it'll be negative, all right, because 3 is always positive. The numerator for this graph, for this equation, no matter what I plug in for x, is always going to be positive. So that's just what these pluses are telling me. If I have this x plus 3 and I plug in a negative 5, what that means is negative 5 plus 3 is negative 2, so that's going to be negative. And that will actually hold no matter what I choose for an x value less than negative 3. It would have worked for negative 3.01, it worked for negative 100, this value is going to be negative. In the same way, negative 5 minus 3 is also going to be negative, no matter what you pick less than negative 3. My overall result is going to be positive, because what I'm saying is the numerator is positive, this bracket's negative, this bracket's negative, a positive times a negative is going to be a positive. So what that means is momentarily the graph is going to look like this, and I'll show you here in a sec. In the middle, I'm going to do the same thing with 0. 0 plus 3 is going to be a positive result, so I'm going to put a plus there, and 0 minus 3 is going to be a negative result. Then I'm going to just multiply, so a positive times a positive is a positive, times another negative is a negative, so that's going to be a negative. On the right then, 5 plus 3 is a plus, 5 minus 3 is a plus, and the overall result is a plus. Okay, supply teacher, I'm going to ask you to hit pause and answer any questions if possible, and for the rest of the class I want you to just fill in that chart to make sure you're good. Alright, now we're actually going to graph this. Now the way it should look is, I know less than negative 3 is going to be positive, so it should look like this. Between negative 3 and 3 is negative, so it should look like this, be negative, and to the right it should be positive like this. Let's see if the graph agrees with me. So what we actually are looking for here, let me make this big so we can see. I'm going to say f of x, oops, not f2 of x, whoa, what happened there? F of x equals x, no, it was 3 over x squared minus 9. And look at that, it fits right in there. Can I hide that? Yeah, I can. Okay, so on the left it's going to be to the left of negative 3, it's going to be a positive value. To the right of positive 3, it's going to be a positive value. And between negative 3 and positive 3, it's going to have, it's going to be negative. Okay. Now with that vote of confidence, I'd like you guys to try one of these for yourself right now. Okay. This is going to be example 2, and then we're going to be done for the day, I think. Okay, I'm not sure how the timing is going here. Example 2 is going to say a graph. This will be more complicated, of course, because it's for you guys. Graph f of x, oops, equals negative 3 over, we'll say, x cubed minus 2x squared, oops, minus 9x plus 18. Now I know what you're thinking to yourself, and I'm going to make this wide so you don't need to worry about the graph for right now. You're thinking to yourself, wow, that's a cubic. I don't know how to factor a cubic. You do. Okay? What we're going to do for this is, remember, you're going to take out a common factor, or I mean, you're going to factor both sides, right? So put a little dotted line down the middle here, factor this and factor this. Okay, if you don't know where to start, start by finding the asymptotes and labeling them on your graph, and then we'll do the chart as a class if you need to. Okay, so supply teacher, can you please hit pause? Then we'll get the class to factor. Alright, here we go. So I'm going to get Luke to start us off here, please. Can you show me how to factor the, whoops, I'll move that up a little bit. Can you show me how to factor the Can you show me how to factor the denominator? Good, that's going to be x squared. Oops. Sorry, x squared bracket x minus 2 minus 9 bracket x minus 2. Okay, great. RA, can you finish up from there, please, or give me the next line? Negative 3 over x minus 2 and x squared minus 9. Great. Hannah, can you factor, keep going here? And that's going to be negative 3 over x minus 2, x minus 3, x plus 3. Alright, and that's a wonderful start right there. Okay? If you got that far, great. We'll show you how to finish up from there. Alright? Alright, Cecilia, can you give me the restrictions, please, or my asymptotes? Go ahead, asymptotes. I'm going to say... Oops. Okay, so my restrictions for x are going to be x cannot equal 2, yep. 3, yep. Negative 3, yep. Good. And y cannot equal 0. Perfect. Okay, so what you're going to do is you're going to go now to your graph. Sorry, I'll leave that on there if you... Nah, maybe I won't. And what you're just going to put on here is you're just going to draw your asymptotes. I'm going to close all this. That last graph was lovely. I'm going to say here x equals 2, x equals 3, x equals negative 3, and y equals 0. I'm going to put all these as red. Whoops, what happened there? I'm going to put all of these as red dashes. Okay, so you can hopefully see how it goes. Okay, so there's my graph right there. I'm going to get rid of this, and hopefully you can see that a little bit. Okay, so there's going to be 4 intervals, hopefully we can see in this case. Okay. The way the intervals are going to go, and do the same thing, f of x. My first interval is going to be x is less than negative 3. The next one's going to be negative 3 is less than x is less than 2. 2 is less than x is less than 3. And x is greater than 3. And I don't know if this is going to work. So the way I got that from is, let's scroll back here. Okay, x is less than negative 3 is over here. X is between negative 3 and 2 is here. X is between 2 and 3 is here. And x is greater than 3 is there. All right, let's go back to my full screen here, and hopefully we can finish this up. Okay, so under the fx column, Cassie, can you tell me what I'm going to write? Okay, good. You're going to write everything here in factored form. So, whoops, negative 3 goes there. X minus 2 goes there. X minus 3 goes there. X plus 3 goes there. Overall, and test point. I'm going to run out of room here, so I'm going to move that over a bit. All right, so my test point less than negative 3 I'm going to pick as negative 10. Between negative 3 and 2 I'm going to pick as 0. Between 2 and 3 I'm going to pick as 2.5. And bigger than 3 I'm going to pick as 1,000. You can pick anything. Now the only trick is for this, okay? So what I'm doing is you're going to sub all these values into each part of this equation. When I sub negative 10 into the numerator, I'm always going to answer with negative 3. So that, whoops, so that's going to be negative all the way across. When I sub negative, oops. When I sub a negative 10 into this one, negative 10 minus 2 is going to be negative 12, which is a minus. Negative 10 minus 3 is going to be negative 13, which is a negative. And negative 10 plus 3 is going to be negative 7, which is going to be a negative. What that means is when I plug a value less than negative 3, this is going to be negative, this is negative, this is negative, and this is negative. So that means I have 4 negatives, so the overall result is going to be positive. So when I draw this graph, it should look upwards like this. Okay. For x equals 0, 0 minus 2 is a negative, 0 minus 3 is a negative, and 0 plus 3 is a positive. So it's going to be 3 negatives and a positive is going to end up being negative. Okay. 2.5. 2.5 minus 2 is a plus. 2.5 minus 3 is a negative. And 2.5 plus 3 is a plus. So overall result is positive. Okay, because we're multiplying a negative times a positive. Let's try again here. A negative times a positive. A negative is a negative. Times another negative is a positive. Times another positive is positive. And note, you can pick any values you want here as long as it's in the domain, right? Finally, on the right-hand side, 1,000. 1,000 minus 2 is positive. 1,000 minus 3 is positive. And 1,000 plus 3 is also positive. Oops, what happened there? What's going on? Okay, so a negative times a positive is a negative times a positive, and so all that's going to be negative. All right. Okay, let's get our graph drawn up here. You can hit pause if you want to, supply teacher, so that the class can get that. And then let's get this graphed up here. Okay. The way this should actually look, if I can make a graph here, is f of x equals negative 3 divided by, that was x, I lost my graph, x cubed minus 2x squared minus 9x plus 18. And there we go. Let's make this full screen and we can hopefully see what that looks like. Now, I'm not worried about how high this goes and all that sort of stuff, okay? As long as your graph fits within your domain. If you take a look now, going back to our chart, less than negative 3 is supposed to be positive, which it is. Between negative 3 and 2 is supposed to be negative, which it is. Between 2 and 3 is positive, which it is. And greater than 3 is going to be negative, which it is. So it fits nicely into our graph. Okay, thank you guys very much. Thank you for playing along. Your homework tonight is going to be continue working on your assignment. I may or may not be here tomorrow. Hopefully I am. And we can get through this. Okay, thanks guys. Bye.